Hi class, this is lesson 10-7. It's finding volume of prisms. Let's go ahead and take a look at the purpose. Today the purpose is to estimate and calculate the volumes of rectangular and triangular prisms. Well, before we do that, we of course have some vocabulary terms. There are three vocabulary terms I'll be looking at. The first one, and at this point I want you to go ahead and turn to the back of your composition books to write this down. The first one is polyhedron. Polyhedron is a three-dimensional object with flat polygonal faces. These four objects here are polygons. They each have flat surfaces, and each of the surfaces represents a specific polygon. Polygons that we're now very familiar with. Our next definition is a prism. Now, a prism is a type of polygon. Now, note, I'm going to go back to a polyhedron. You'll notice when I go back and forth that there's this triangular object called a tetrahedron that disappears when we talk about prisms. That's because a prism is a specific type of polyhedron, a polyhedron with two congruent parallel bases. Whereas these objects have bases that are congruent and parallel, this particular object does not. This object has four, it's called tetra, meaning four. It has four sides, and there's not a parallel side to any one of these other sides. So those are polyhedrons, and prism is a type of polyhedron, and got rid of that tetrahedron because it has to have parallel bases. For these objects, of course, there's a parallel base here and one down that we can't see. Parallel base here and down below, parallel base here and down below. These two actually have a couple of parallel bases that we could describe and talk about, which make them prisms. Finally, we're going to talk about the word volume. And the volume is a number of cubic units of space inside a three-dimensional object. It's related to area. Area is two-dimensional. Volume is three-dimensional. So we're not only talking about space on a plane or space on a flat surface. Now we're talking about space inside of an object. And we call that cubic amounts of space or cubic units of space. Well, let's look at volume. Volume from the standpoint of a prism. Here we have a question that says, how many centimeter cubes fit into this rectangular prism? Here we have what looks to be like an aquarium. And at the very base of it, we have a 5 centimeter by 2 centimeter dimension, and then we have a 3 centimeter height. Well, how much space is inside of this? Well, if we start with the base, at the bottom here, it's 5 by 2, meaning that there are a total of 10 blocks, 10 centimeter cubes that can fit in this this first layer, this base layer, which again defines the space in that bottom layer. So there are 10 cubes. 5 times 2 just happens to be 10 as well. Well, there's other layers that we need to add. We have to add 2 more layers to that. So if we add an additional layer on top of this 10, well, then there's 20 in the second layer. And then when we add another layer of 10, there's 30. So the amount of cubic centimeters inside of this particular rectangular prism is a total of 30 cubic centimeters. Okay. Now we can arrive at that more simply with this formula. Here the formula is volume equals base times height. So what it's saying is the big B indicates the area of the base. So this layer right here. And we know what the area of a rectangle is, which is this base, by multiplying the 5 times the 2. So volume here equals 5 times 2, and then multiplied by the height. The height here happens to be 3 centimeters. volume equals 10 times 3. So we know 10 cubic centimeters is contained in this bottom layer. And then we multiply it by the 3 layers that are there, and our volume becomes 30 centimeters cubed. Notice the cubing right there. Okay. Next, we're going to go through a couple of problems. One example here is this rectangular prism that's 20 by 36 by 80 inches. First thing we do is make sure that we've written down the formula. Volume equals the big B, meaning the area of the base, times the height. I'm going to go ahead and substitute numbers. The area of the base for a rectangle is 36 times 80. So we're going to write 36 times 80. And then multiply that by the height, which is 20. Now I'm going to shortcut this process, and I'm just going to draw an arrow. When I multiply all those together, I come up with 57,600, and then my label inches cubed. Okay, so I didn't necessarily show you my work, but I did show you what I multiplied by to get that final answer. All right, our second example. Second example here is a triangular prism where the bases, remember the bases are parallel and congruent to each other, so those two triangles there are the bases, even though it's not resting on a base like we would think. Those are the two bases. The same formula for volume is volume equals the area of the bases times the height. In this case, I'm going to go ahead and copy down the formula here. In this case, we're dealing with triangular bases. So if we recall, for a triangle, area equals half base times height, right, for just the area. So we're going to use this to figure out what the big B is, in terms of area of the base. So I'm going to write down half, and then base times height. For this, it's going to be, for this triangle, it's 4 2/10 times 2 8/10. And that's the area of that triangular base. Okay. And then we have to multiply it by the height. The height of this, even though it's laying on its side, is 5. So we multiply 1/2 times 4 2/10 times 2 8/10 times 5. Again, I'm not going to show you all the calculations here. Of course you will when you go and work through these problems. The answer comes to 29 4/10 cubic meters. Notice I used a different notation this time. Okay. Next is to complete the problem. And we have another triangular prism here. We're going to find the volume of this, and we're going to write down first the formula for volume, which is volume equals the area of the base times the height. Again, the bases here are not the rectangular sides, but the triangular sides, because they are parallel to each other and are congruent. They're the same size and same shape. So we know that in order to find the area of this base, the area of this triangle, we have to use area equals half base times height. That's little b. So we substitute that in our equation for b here. Okay. The area of this triangle would be then 1/2 times 3 times 6 times the height, which is 8. Now it's your turn. We'll see you in class.